and welcome to the session. In this video we'll be discussing about chi-square statistics. Basically chi-square statistics is a test that measures how a model is as compared to the actual observed data. So it's basically one of the hypothesis testing method. We have discussed about the other two hypothesis testing method in the last two videos, z-test and t-test. So this is also one more hypothesis testing method, and basically the chi-square test involves checking if the observed frequencies in one or more categories will match the expected frequencies. And in fact this is one of the most common non-parametric test. Why do we say this is a non-parametric test? Is because we use this for data that doesn't follow any kind of assumptions of parametric tests, like assuming that the data is a normal distribution. We saw that, right? In z-test we assume the data is a normal distribution, and in t-test we assume that the data follows a t distribution. But in chi-square test there are no such assumptions, and hence it is a non-parametric test. So if you want to test a hypothesis about the distribution of a categorical values, then you can go for chi-square test or any other kind of non-parametric test. So basically when you are doing hypothesis testing for categorical variable. Now when I say categorical variable, it can be a nominal value, it can be an ordinal, which can represent groupings like such as a species or nominality, nationality. So these are all examples of categorical variables. So, and also since in such non-parametric tests, the data sets will have very few specific values, and hence they cannot have any kind of normal distribution. In such cases you use chi-square test. So to quickly summarize, chi-square test is a non-parametric test. It can be used when the data sets are having a very few specific values, when the data sets have categorical values like nominal values or ordinal values, and also we use this when the data sets doesn't follow any kind of a normal distribution or any kind of assumptions which are normally a parametric test will have. So there are two types of chi-square test. Chi-square goodness of fit test, where we use this method if you want to have a single measurement variable. The second type is chi-square test of independence. We use this method if you have two measurement variables. So let's see two examples for each of this to get a better idea. So this is an example for the first category or first type, that is chi-square goodness of fit test. So as I said, in this you will just have a single measurement variables. So this is a data set where you have in the column 1 the name of the bird species, in the column 2 you have the frequency of visits to the bird feeder by these birds. So you can see house sparrow has a frequency of 15 visits during a 24-hour period. House finch has a frequency of 12. So here you can see that we just have measurement of one variable, and hence the first type, that is chi-square goodness of fit test, would be more suitable, right? So to test whether these observed frequencies are significantly different from what was actually expected. So this is a second example which is better suited for the type 2. The type 2 is chi-square test for test of independence. In this example you are basically having a table of how many people are right-handed and how many are left-handed, and American, how many are right-handed, how many are left-handed. For a Canadian, how many are right-handed, how many are left-handed. So basically you have two, as you can easily see here, you have more than one variable here, right? You have two measurement variables in this case. Two measurement variables, right-handed and left-handed, and hence the type 2 is more suitable. Using type 2 you can test whether this is the observed frequencies, right? So you're going to test whether these observed frequencies are significantly different from the frequencies which are expected. Now let's see when to use a chi-square test. See, you can use a chi-square test for hypothesis testing about whether your data is as expected or not. So you have a data set and you want to test whether the observed data is as expected or not, then you go for chi-square test. So basically the idea here is you're comparing the observed values with the expected values, and through that you are able to tell that if the null hypothesis is true or not. So basically let's see how we can perform the chi-square test. Like in all the other previous hypothesis testing, the process remains the same. First few initial steps will remain the same. The first step is we define the null hypothesis and we define the alternative hypothesis. Then the second step is also same. We decide on the alpha value. Basically this involves deciding the risk you're willing to take when you're drawing some kind of a wrong conclusions. For example, if I say alpha value is 0.05, that means I have decided on taking 5% risk of concluding whether the two variables are independent when in reality they are actually not. Okay, so that is the meaning of this alpha or the significance value. So this step is also the same like in other previous t-test and z-test. You decide the alpha value. The third one is now you check the data for errors. So here is where you actually apply your chi-square test formulas. Next you check the assumptions. Now you are going to check whether the null hypothesis is true or not. And then finally you perform the test and draw your conclusion. So the steps will remain the same like in other tests. The only difference is here where in the third step you are going to apply the chi-square formulas to detect the data for errors, to check whether the observed data is equal to the expected data or not. Then finally you draw a conclusion whether the null hypothesis is true or not, or whether you have got a significant result or not. So the basic idea again is to compare the actual data values with what is expected, and therefore the null hypothesis you have to prove whether it is true or not. So how do you calculate the chi-square test? This is the formula where you have the sum, this chi-square, this is a notation of chi-square is equal to summation of I to 1 OI minus EI the whole square divided by EI, where O is the observed frequency, E is the expected frequency, right? And when you're talking about, again here also you have the concept of degree of freedom. You can calculate the degree of freedom, and C is the number of categories. If the number of categories is C, then the degree of freedom is C minus 1. So basically you can calculate chi-square test where it involves finding the square difference between actual value and the expected value, and then divided by the expected data values. Now this formula will be applied for each data point, and then later we sum it up. Okay, so then after you do this calculation, you compare this test statistics to a theoretical value, the theoretical value which will give from the chi-square distribution. And also the theoretical value, how do you get this is just like how we have done in z-test where we refer the z table, in t-test we refer the t table. Similarly now we have the chi-square distribution table from where I will find the theoretical value. Depending upon that table I will be able to get the alpha value and the degrees of freedom for the data. So the advantage of going for chi-square test is it will help in detecting the duplication of data, and also it helps to remove the redundancy. So in the next class, we will see how we can apply this procedure for finding the chi-square test. So thank you so much, and please subscribe to the channel. Thank you.